then we saw how difficult it is to train models on a lot of GPUs doing distributed computing. So our goal, it's still our goal, was to simplify that, to simplify the way data scientists can train big models. Right now, you have these open source models where you can train them on your data and fine tune it. You don't need tens of thousands of GPUs to do that, right? Open source Llama 2, it's free for research and commercial use, as they say. So that's really, really exciting.
Hello, and welcome to the Cognitive Revolution, where we interview visionary researchers, entrepreneurs, and builders working on the frontier of artificial intelligence. Each week, we'll explore their revolutionary ideas, and together we'll build a picture of how AI technology will transform work, life, and society in the coming years. I'm Nathan Lebenz, joined by my co-host, Eric Torenberg. Hello, and welcome back to the Cognitive Revolution. Today, I'm joined by Dr. Ronen Dar, CTO and co-founder of Run AI, an Israel-based company that helps enterprises train and deploy AI models by optimizing their GPU usage. With companies around the world racing to adopt next-generation AI systems, we first discuss Run AI's technology and what differentiates it from other solutions in the market, before then getting Ronen's perspective on today's market for AI chips, from the ongoing shortage, which he expects to go on for a while at least, to the process and best practices by which companies secure their compute capacity, to the relative prices across major providers, the prospects for chip makers other than NVIDIA to meet the soaring demand, the geopolitics of chip production, including the view from Israel on the US-China rivalry, and finally, the prospects for so-called compute governance to effectively control the pace of AI development, whether in China or anywhere else around the world. As I mentioned on our July 4th episode, one goal we have for the second half of the year is to speak to more researchers, builders, and entrepreneurs who are working on AI outside of the United States. And this conversation with Ronen, who combines deep technical expertise with a global strategic outlook, was a great first step in that direction. If you have any other suggestions, please do let us know. You can always email us at tcr@turpentine.co or DM me on Twitter, or should I say, x.com, where I am at Lebenz. Finally, for now, I encourage everyone who hasn't already to circle back to my AI scouting report, which is posted exclusively on our YouTube channel. It really is the best way that I know to get up to speed on the fundamentals of AI progress and the most important recent development trends. And it's been gratifying to see that the YouTube audience seems to agree. With that, I hope you enjoyed this enlightening conversation about the physical substrate powering the AIs of the future with Dr. Ronen Dar of Run AI. Ronen Dar of Run AI, welcome to the Cognitive Revolution.
Hey, Nathan, good to be here.
So I'm excited to talk to you about all things AI workloads, GPUs, orchestrating them, and kind of the future of where we're going as really a global AI user base and market over the next year or two. For context, you are the CTO and co-founder of this company based in Israel, Run AI. So for starters, tell us about the company and what sort of AI workloads you're orchestrating for folks.
So we Run AI. As you said, we're based in Tel Aviv, Israel, but we have people all around the globe. We have offices in New York as well, and in California as well. And as you said, I'm now in California. And so I'm spending a lot of my time here in the US. And okay, so we Run AI, and we started in early 2018. We're starting to run since then. So we're an AI infrastructure software company, and we help companies to train and deploy AI models. We're doing a lot of stuff, orchestrating AI workloads and orchestrating GPUs. And I think we're bringing in a lot of technology very close to the GPUs, to the GPU level, and to the cloud native world, Kubernetes world. So we bring a lot of technologies in these two aspects of optimizing the usage of GPUs and optimizing how workloads are being orchestrated and scheduled in cloud native environments. And we bring a lot of tools for ML teams to easily deploy, train their models. And we're working with big enterprises right now. Our solution is quite horizontal. So we're working with big enterprises in the gaming industry, with Sony is one of our customers. We're working with the finance industry, the BNO and Benjamin Mars customers. We're working with research institutes, so MIT, Honeywell, the AI research on top of Ronen Dar. And we're seeing this exciting things that are happening in our space. We see it the last 6-7 years, and amazing stuff happening right now. So it's very fun to be in the place that we are right now.
Maybe give us a little bit more of the history, because it's funny, it's only been 5 years, right, since you've founded the company, but obviously a lot has changed. The types of models that were available to run and the kind of scale of training runs that people were attempting in 2018 is obviously, much smaller than what we have today. So what was kind of the market that you anticipated going after that inspired you to get involved in starting a company? And then how has that, how has the actual market as it's shaped up deviated from your expectations?
Yeah, that's a great question. So in fact, right, we started in 2018, and when we started, it was all about computer vision applications, right? So I think the big breakthrough in the industry for machine learning and deep learning happened around 2012, 2013, with the ImageNet competition and researchers from Toronto University training AlexNet and doing this big breakthrough in how machine learning models, deep learning models can get insights from images and videos. And back then, AlexNet was trained on 2 GPUs. That was the big breakthrough back then in 2012. So 2 GPUs, right, to train the state-of-the-art models from scratch. And then we saw an interesting trend of people training bigger models with more parameters, using more data, and using more GPUs. And so a few years later, 2015, ResNet came out, and ResNet was already trained on hundreds of GPUs. And so we saw this trend of computer vision models being scaled from a few GPUs to train the state-of-the-art models to hundreds of GPUs. So 100x increase in the requirements to train state-of-the-art models back then. So we started running it back then. We saw how difficult it is to train models on a lot of GPUs doing distributed computing. So our goal, it's still our goal, was to simplify that, to simplify the way data scientists can train big models, and just to allow them to train huge models very easily, just one click, on doing distributed computing. So we started with that, and then we saw that there are huge problems around distributed training, but around also how GPUs are being utilized, how GPUs are being orchestrated, and how ML teams are getting access to GPUs. So we saw a lot of inefficiency there, a lot of complexities around just getting access to GPUs. And we solved those problems as well. We bought, as I said before, we built a lot of technology around that aspect of just getting access to GPUs and utilizing them efficiently. And I think we saw in 2017, 2018, with a new breakthrough in natural language processing. So we saw again the same trend that we saw in computer vision. People trained state-of-the-art models, NLP models, language models, in 2018 on hundreds of GPUs. So I think GPT-1 was trained, around hundreds, using hundreds of models. This stage, GPT-4, just according to rumors, right now GPT-4 is closed source. So according to rumors, GPT-4 was trained on more than 20,000 GPUs. So in a 4-5 years time frame, we went from training state-of-the-art models on hundreds of GPUs to tens of thousands of GPUs. So another 100 increase in the computing requirements for training state-of-the-art models. Models become bigger, more data, more compute. So we see this trend once again, and we see now a lot of companies are seeing what can be done with generative AI and language model, and they are rushing to bring those capabilities into their organizations. For sure, AI is going to transform industries, and people see that And I think people need to take action and bring AI into their organization and see how their organization, how their business, how their industry is going to be transformed by AI and work on that. So we are helping our customers to do that. Now it's about the large language models, about generative AI models and how to train them. A lot of people are still training computer vision models and models that are much smaller than those language models. But those models will stay, so we're helping with those models as well.
So where do you play in the overall stack or architecture of all this kind of stuff? And I mean that maybe in a couple different ways. Like conceptually, there is obviously a significant divide between training and inference. And then also there's kind of, vertical integration, right? You partner with NVIDIA. I wasn't quite able to figure out, like, are your customers primarily like managing their own physical computing resources and you're a software layer that complements that? Or do you have, deployments across all the major public clouds? Describe kind of how far the tentacles reach.
So we can run our platform wherever the customers want their GPUs to run. So we have customers run the platform on premises. We support learning app solutions. So we have a lot of defense customers. We are with no connection to the internet. And we have a lot of customers in the cloud and managing small clusters of GPUs with tens of GPUs. And we have customers running thousands of GPUs in just one cluster, managing it all on AWS or all the way. We have also customers in Azure and Google. So we're the so-called like hybrid solution. So with Run AI, you can get just one platform with which you can run workloads on premises, in the cloud, in any cloud, and it's all for the same interface, for the same with the same tools. And so we're in the stack, we're running with Kubernetes, with cloud native, so we can run on any Kubernetes layer. So it can be Kubernetes, vanilla Kubernetes. You can run on any managed Kubernetes solution of the cloud providers, or with Reddit OpenShift. And then users and analytics, they can use our tools to train their models or deploy their models, right? In first, it's both training and inference. And we're really taking an integrable the approach. So we can integrate with any tool that runs on top of Kubernetes. So we're working with a lot of tools in the ML ecosystem, experiment tracking tools, other tools, orchestration, workflow orchestration tools. So being open, I think it's really important because the field moves so fast and new tools are being created every day. So that was one of our way to operate, right? We want to be as open as possible.
A lot of that sounds, we just had another episode with a couple of guests from mosaicML. And, I've made a couple jokes about the cognitive revolution bump that obviously, led them to a good outcome very shortly thereafter. I don't want to get overly bogged down in kind of comparing, one company against another, but how would you kind of compare and contrast the business that you've built versus how you kind of see Mosaic? Is it just the sort of thing where business is growing, the industry is growing so fast that you guys don't even worry about competition? Or do you see like that there are kind of head-to-heads and you have like meaningfully, different positioning in the market?
Okay, so Mosaic, first of all, they started after us. So they started, I think, like 2.5 years ago, and we started 5 years ago. Mosaic is really have clear focus on generative AI and large language models. We're more general than that. But I think that the main thing is that we came and we built our platform very much from the bottom up. So we came from the GPU itself, on the hardware itself, and we saw all the issues and problems we utilize on GPUs. So we really, when we built our platform, we really understood very well the software stack that runs on top of GPUs, and we saw the limitations of those software libraries, software frameworks.
Hey, we'll continue our interview in a moment after a word from our sponsors. Hey, everybody. If you're a business owner or founder like me, You'll want to know more about our sponsor, NetSuite. NetSuite provides financial software for all your business needs. Whether you're looking for an ERP tool or accounting software, NetSuite gives you the visibility and control you need to make better decisions faster. And for the first time in NetSuite's 25 years as the #1 cloud financial system, you can defer payments of a full NetSuite implementation for 6 months. That's no payment and no interest for 6 months. And you can take advantage of the special financing offered today. NetSuite is #1 because they give your business everything you need in real time, all in one place to reduce manual processes, boost efficiency, build forecasts, and increase productivity across every department. More than 36,000 companies have already upgraded to NetSuite, gaining visibility and control over their financials, inventory, HR, e-commerce, and more. If you've been checking out NetSuite already, then you know this deal is unprecedented. No interest, no payments. So take advantage of the special financing offer with our promo code at netsuite.com/cognitive. netsuite.com/cognitive to get the visibility and control your business needs to weather any storm. That is netsuite.com/cognitive.
Omneky uses generative AI to enable you to launch hundreds of thousands of ad iterations that actually work, customized across all platforms with a click of a button. I believe in Omneky so much that I invested in it, and I recommend you use it too. Use CogRev to get a 10% discount.
And we built two main components, I think. So one of the components, I'm the CTO, so I like to run the technology. So we built one thing that we built is GPU optimization layer. So we did what we call like an API level of virtualization, CUDA level virtualization. So we sit at the CUDA level and we intercept CUDA calls and we control access to GPUs. And we do that for enabling better access to GPUs. So with that layer, workloads can share a single GPU. So we have this feature called GPU fractionalization. So we can fractionalize one GPU that can be shared. And we know how to swap memory between CPU and GPU. So people can all provision GPUs to run bigger models or more models on the same GPU. So essentially, we bring a lot of capabilities into utilizing GPUs much better. The second component is more scheduling and orchestration. So we saw that Kubernetes is the state-of-the-art infrastructure and management framework today in clouds. But Kubernetes was built for running microservices on commodity CPU, whereas AI workloads are totally different. AI workloads are really compute intensive, and they're running on GPUs. There's a lot of experimentation in terms of how data scientists and machine learning engineers are running their workloads. And we saw that there are a lot of scheduling capabilities missing from Kubernetes that are actually available in other fields like high performance computing field, like HPC field, scheduling capabilities on the Hadoop ecosystem. Yarn scheduler is an amazing scheduler that was built like 10 years ago, but it got a lot of scheduling capabilities that were really needed for running the Spark workloads. So we took concepts on those worlds, from HPC and Yarn, and we brought them into the Kubernetes world. So we're bringing a lot of batch scheduling capabilities, ability to preempt workloads, to queue workloads, and do GAG scheduling. So a lot of GAG scheduling, and at the end, what it allows teams to do, it allows them to, first of all, get a guaranteed quota, a way to get access to their GPUs. But they are not limited to that guaranteed quota. They can always go above the quota and use more GPUs and run more workloads if there are available GPUs in their clusters. If there are idle GPUs, we allow other people in the organization to use those GPUs. So essentially, those scheduling capabilities are bringing again a lot of efficiency into GPU clusters and much more availability of GPUs. So suddenly, MSDs, it becomes much easier for them to get access to more GPUs very easily on demand. So we're increasing the efficiency of how GPUs are being utilized, and we're increasing the availability of GPUs. And availability of GPUs is a serious aspect, a serious problem. And so I think that is really unique for us. The fact that we bring a lot of efficiency and a lot of increase in availability of GPUs, I don't think that anyone else in the world is doing that. So bringing that, we're also doing a lot of simplicity. So we're helping MFTs to easily train their models and easily deploy their models. So we're invested heavily, still investing in providing tools and ways to abstract the complexity involved with just running workloads and just training models and deploying them. So I think with better teams, without the right infrastructure solution, without the right platform, they would spend like 90% of their time on infrastructure, on setting up libraries, setting up drives, setting up a lot of stuff. And for them to scale out their experiment is really difficult. If they are running just one experiment and they want to run it instead of one GPU on a lot of GPU, like tens of GPUs, that's typically really difficult. Or if they want to run a lot of experiments in parallel, so scaling out those experiments, that's also really difficult. So we bring a lot of tools to allow researchers and AI practitioners to iterate fast, run, scale up and experiments very easily. So for us, I think it's about simplicity and about bringing a lot of efficiency. And then the efficiency part, I think no one else provides the value that we bring. We have customers that have 4x and even more than that increase of their GPU utilization, increase in their GPU availability. And so together with the simplicity, I think we bring a really unique offering to enterprises on the world right now.
Yeah, okay, cool. That's very helpful. And it is certainly in the context of the shortage that, and I want to kind of, turn in a second toward just kind of the macro context that's driving, all of the concern and focus on utilization, right? These things they're not cheap by default, and they're getting bid up at the current moment. So that puts you in a position to, be even more valuable. Am I understanding correctly that like this sort of assumes a dedicated capacity? Because when you say like it could be more efficient, that could mean, if you're buying like on-demand access, that you buy less. But as you talked about it, it sounded more like there's an assumption of certain, either physical infrastructure that a client has, or at least some sort of contractual commitment that now they have a certain amount of capacity. Let's make the most of it and not have our data scientists, waiting around when they could be getting to work.
So that's another good question. So for what we see, that big enterprises, big organizations, they usually secure access to GPUs. So just getting access to GPUs, to a lot of GPUs, that could be really difficult. If you go to your AWS account manager and you ask them to increase the limit of your GPUs, GPU instances, so you can try and do that. And if you want to increase your limits, going from 10 GPUs to 1,000 GPUs, for example, that's a big deal. You get a lot of questions while trying to do that. So I think just securing access to GPUs and having them available for you, that's a big problem. So it makes the enterprises right now and buy and reserve those GPUs. So we see a lot of enterprises using reserve instances of GPUs, huge clusters of GPUs. That's for enterprises. That's what we see. For sure, reserve is something that is being done when it comes to GPUs. Now, when it comes to smaller companies, and for them, on-demand access to GPUs is totally relevant, right? Many startups won't want to do a big investment upfront and buy GPUs. So many of them are using on-demand, right? Or maybe it's a combination of reserve and on-demand. But then in that case, we have also a lot of startup companies work with us and our customers. In that aspect, what we get is clusters that are elastic. So those clusters can grow or shrink. Maybe they have like multiple clusters in different regions, and just deciding on where to run the workload on which region and how to get to find available GPUs in the right regions and run the workload, that could be a challenge. So we're helping also customers just to get access to clusters that might be available in different regions, and they might be a dynamic cluster, right? You can spin up or down. So for sure, it's about reserved and about demand, on-demand instances as well.
Yeah, so let's talk a little bit more about access and kind of the nature of the market. And I don't have a lot of experience in this for context, and I imagine most of our listeners don't, right? Unless you're one of a small pocket of people at a company that's going to make this kind of capital investment or commitment, you're probably like me and you are mostly paying the hourly rate for GPUs, as you go. And that's worked fine for me. I haven't done anything at huge scale, but obviously the biggest companies in the world, are kind of waking up to the fact that there is this shortage. Maybe for starters, can you just tell me, like, how do you understand the shortage? How bad is the shortage? Like, are we now in a period of like eternal GPU shortage, like until further notice? And what do people actually go through to buy? Like, I in Googling this, it's not super, or using even Perplexity to search for information about this, it's not super obvious. Like, you can go get one here on eBay, and then there's like an H100 on Amazon in a random spot, but it's not really obvious like how the big buyers interact with NVIDIA in the first place to even get bulk orders. So maybe you could demystify some of that for us a little bit.
I think, first of all, I think the GPU shortage relevant to whoever buys GPUs, for their on-premises environment, right? Or for companies or people trying to get access to the high-end, the most advanced, the newest GPUs in the cloud. So also getting access to those newest GPUs, that can be a challenge if you need a lot of GPUs. I think what we have seen in the last 6 months is that the demand to GPUs increased amazingly fast. It grew in a way that NVIDIA didn't anticipate. OpenAI came out with ChatGPT, and they showed to the entire world what can be done with the LLMs and generative AI, right? And a lot of companies, including Microsoft and all the cloud providers, and include Elon Musk with his new company, he went and bought 10,000 GPUs just a few months after ChatGPT went out. So a lot of companies and all the cloud providers went to buy more GPUs from NVIDIA. So that created a big jump in the demand for GPUs. With hardware, compared to software, it's much more difficult and much more complex to supply the demand when you have unexpected changes in the demand. So that's what happened. And for NVIDIA, they need to change the way and the pace of which they manufacture those GPUs. So we're speaking about real machines that are actually manufacturing those GPUs. To manufacture more GPUs, you need more machines. And that takes time to build, to set up those machines and let them operate. So supplying that demand and bridging on that gap between the demand and the supply when it comes to hardware, that takes some time. And I'm sure NVIDIA are working on it. And I'm sure that they are increasing the pace in which they manufacture their GPUs. And I think that the GPU shortage will go away with time. Right? I don't know how much time it will take for the shortage to go away, but a lot of companies are still now waiting for their GPUs, or the GPUs that they order for their H100. So H100 is the newest GPU, right? People can buy, and a lot of others are waiting in line. So that's the GPU shortage. I think it's really interesting because what we see, we spoke about the trend of using more and more compute to train AI models. Yeah, I think for the first time, we're seeing also a huge increase in the demand for GPU power for inference, for running those models in production. So LLMs, generative AI models, are so huge that usually they don't fit into the memory of one GPU. So if you want to run state-of-the-art models with hundreds of billions of parameters, typically you need a few GPUs for that, like 4 GPUs, 8 GPUs, maybe more than that. So I think now we're seeing a 10x increase in the compute requirements for inference workloads. And that's significant. That's significant for every company that is actually providing and running models like OpenAI and like GitHub with their Copilot, right? I'm sure there are other scale there. So Microsoft, between OpenAI and GitHub, with their Copilot, they need to manage a lot of GPUs. So for inference, for sure, that contributed to the demand for GPUs was very significant. And I think what we've seen is that the pace in which AI application and AI innovation is happening is much faster than the pace in which GPU or the hardware is being moved forward, is being progressed. It relates to more slow in that it relates to other issues as well. But AI, the aerospace AI innovation moves at an exceptionally fast pace, much faster than the capabilities of new hardware. So when that happens, you're getting more and more demand for hardware. And then you're getting these problems of demand grows too fast, the supply doesn't able to catch up. And so I think that my prediction is that this is not the last time that we are seeing GPU shortage. I don't know when will happen the next GPU shortage, if or when. I think it will happen again. But now it's like a temporary thing. It will be closed. But I think that it will happen again, GPU shortage. It has major consequences. Yeah, I think it has major consequences on the industry, on how companies are operating, on the cost of AI. So a lot of interesting aspects related to that.
So how does it actually work today if you want to start your own little cluster, right? If you are, let's say you're in, I'm not sure what, a relevant threshold would be. Obviously, as you said, leading clusters now getting into the tens of thousands. Inflection, AI just made this headline with a huge raise, I believe, with NVIDIA as a backer. And, a lot of that's going to get plowed right back into the chips. So, I mean, at the highest level, there's clearly some strategic deal making going on where, NVIDIA is kind of investing in the people that it's going to be then willing to ship the most chips to. But how does it go if I just want 100 H100s or 1,000? Do I contract directly with NVIDIA? Is there a secondary market that tends to kind of, are there futures contracts that people sort of trade in, and then ultimately, because pricing seems fairly dynamic, right? I'm seeing headlines that are H100s now cost $40,000. Presumably that's not, NVIDIA changing the I couldn't even find a price on their website. So how does that actually work in practice to go through this buying process?
There are a few decisions that one needs to make. I think one of the first decisions is around where to invest. Is to invest in a on-premise environment and just buy GPUs and then operate those GPUs by yourself, or whether to go with a cloud solution. And when I'm saying buying GPUs and operating an on-premise environment, not necessarily on-premise environment, it can be also a co-location, or someone is managing your GPUs in some co-location environment. But still, it's not managed by a cloud provider. It's managed by a co-location provider. So co-location or premises, that's one thing. Cloud is another thing. Deciding there are some trade-offs cost, and there are these huge, interesting trade-off there. So that's the first decision. So if you go and you choose going for cloud, then you need to choose the cloud provider. You can choose multiple cloud providers. It's not necessarily has to be AWS, Google, or Azure. Right now, we have amazing security cloud providers, modern cloud providers like Lambda Labs and Co. We're working with both of them, and both of them have amazing offering the GPUs and then provide access to GPUs. So you can go with that as well. So that's one thing. On premises, that's a totally different story. Then you need to decide on from who to buy the GPU. It could be from a NVIDIA representative, or it could be from resellers. It's another story. And then it's about choosing the right GPU type, right? Whether you want to go to the highest and the newest GPUs, H100, or you're saying, okay, I'm good enough with secure access to V100 or A100. That would be good enough for me, and the cost will be reasonable. So I think there are some trade-offs around that. There are some trade-offs not just relating to GPUs. There are some trade-offs relating to storage. Where are you storing your data? How performant is it? And questions around networking. If you're running a small-scale experiments, or maybe networking is not that important for you. It's like Infinity or even NVIDIA. NVIDIA, those are interconnects are connecting between GPUs. So maybe those aren't that important for you. But if you do train models on multiple GPUs or multiple machines, then networking becomes really crucial for your performance. So then you need to get some decisions there as well. So it's those decisions combine cost, performance, and needs of use, I guess. So it's really, yeah. So we're seeing customers just building huge on-premises environment and still securing access to GPUs in the cloud. And we see customers doing just cloud secure access to GPUs in different clouds. But the world right now, I think everyone are assuming multi-cloud, hybrid cloud is the optional, and it's actually the preferred solution because you don't want to just lock yourself to one cloud provider. So we're seeing enterprises choosing more than two providers or on-premise and a cloud solution.
Prices today, an A100, what I saw on Amazon, it was like $7,000, and H100 I'm seeing $40,000 in headlines, but I'm feeling like that is probably more a reseller price, not like what people are mostly paying. Could you give us general guidance on like what these things actually cost in the market today?
If it's cloud prices, then they are all available, right? Your cloud providers are publishing the prices, so it's A100 can cost, one machine can cost between $30 to $40 an hour. So that's really expensive. H100 will be more expensive. They are still not available on AWS. I think they are available on Azure, for example. H100 are available on smaller cloud providers. Like CoreWeave are already offering H100. So you need to pay a lot for the newest GPUs, but they will be more performant. So it's important to understand that it's not just about the absolute cost of the GPUs, it's also about the performance. Because if your GPU costs 2 times more, but your workloads are running 4 times faster on those GPUs, so yeah, it's actually like the better solution for you, right? It's both cheaper and faster. So H100 is, according to NVIDIA benchmarks, much better, much more performant compared to A100 and previous GPUs. Usually GPUs become more and more performant, right? The actual numbers around the performance increase are really dependent on the workloads themselves, but they also come up with higher costs. Now, when it comes to on-premise, if you go to NVIDIA and buy GPUs, state-of-the-art DJX machines, then you can end up paying hundreds of thousands of dollars for one machine. It would be though very high-end, very performant GPU machine, but you pay hundreds of thousands of dollars.
One quick follow-up on the on-demand pricing, because when I was researching for this, I found Lambda Labs seemed to have the lowest A100 price that I was able to find online, which was just over $1. I think it's $1.10 an hour. And they quote AWS prices at being $4 an hour. Were you maybe citing something different there, or is that accurate in your understanding?
Okay, so I said between $30 to $40 an hour for a whole GPU machine with 8 A100 GPUs, 8 packs. So that's on AWS, right? Yeah, so that's one of the advantages of Lambda. Lambda Labs, they offer significantly lower prices. That's one of their advantages for sure.
How do you see it? Well, how is that sustainable? I mean, I understand there being a big delta between making an upfront investment in an on-premise physical hardware, even if you're co-locating it, whatever, versus, the flexibility of the cloud. But it's surprising to me that there would be a 4x difference, especially in the presence of companies like yours that are multi-cloud and help you kind of, optimize and shift around. How do you understand that 4x difference in on-demand pricing?
That's an amazing question. I don't know. I really don't know. It's an 4x. I agree. It's a lot. It's a big difference. I can just guess, but I think it's an interesting question to ask some that for sure.
Yeah, their H100 pricing is $2 an hour, basically. So they're selling the H100, renting the H100 at still half, though, of the AWS A100 price, which is definitely pretty confusing. Okay. Well, yeah, I'll continue to try to figure that one out. So let's maybe move to, and this, I don't know if this will be kind of in scope or out of scope for your business, because if I understand the technology as you've described it, you're at the CUDA layer, which is the NVIDIA proprietary software layer, which I would say many people, from what I understand, and I haven't explored other alternatives, but from what I understand, that is often said to be one of the huge value drivers, is that the software actually works. And then you're kind of injecting another layer into that kind of strategic advantage that NVIDIA has, and even adding more functionality. But I was kind of also curious, like, what other chips are relevant today, or what kind of other chip efforts are relevant today? Obviously, NVIDIA has got huge demand, and the stock price reflects that, and people are waiting for their things. Like, do you guys see yourselves trying to partner with other chip makers? And whether you do or don't, I'd love to get your take on kind of what other chip makers are going to be relevant over the next few years as AI just continues to presumably scale and scale and scale.
As you said, we're sitting in different layers of the software stack. So we're sitting in the CUDA layer, and we're sitting at the Kubernetes layer. I'm sitting on top of Kubernetes layer, with all the tools that are running on top of Kubernetes. So we're sitting in different layers, and we're working very closely with our layers, and we're working very closely with Kubernetes providers like Rebel and all cloud providers. And I think the market for AI chips is really interesting. There are a few players, as I see it. So NVIDIA, of course, people say that NVIDIA has 87% of the market. That's a big number. The players in the market, as I see it, first of all, there are cloud providers. So AWS and Google, they have their own chips, and lots of them are building and working on those chips in Israel. So Israel engineers are amazing. They are really good with hardware, and they are really good with software as well. And so Amazon and Google are building their AI chips here in Israel. At Intel as well, NVIDIA is also investing in Israel heavily, and they bought Mellanox for their networking. Mellanox is an Israeli company. So
that's all fabless design, right? There's no actual. Are there fabs going in as well? Or I'm understanding this to be the design layer.
No, that's fabless. That's really interesting. Now Intel becomes like from Intel now is Intel always had their own fabs for their own usage, and now they're going to a direction where they offer their fabs to others. But that's another interesting topic. But in terms of the AI chips, all of those players they are fabless. AWS, they have already chips for training and chips for inference offered in their cloud. Google is already for several years, I think more than 5 years already. Their GPUs is offered in their cloud. There are players like AMD and Intel. So AMD are really a strong competitor because their GPUs are used in a significant way in the gaming industry. So they are strong there, and their GPUs are really good. Their technology is really good. So they are a strong competitor. We're starting to see more and more AMD usage. We have customers running workloads on AMD. And Intel is also investing. Intel also investing in Israel, building those chips. And there are startups, a few of them, that are also offering their own chips. And that's interesting. And as you said, I think NVIDIA right now is controlling the market. It controls the market because of their software stack, because of the software ecosystem. So it starts with the CUDA level, but it goes much beyond that. So with VIA is investing a lot of efforts in just getting out a lot of software libraries, software frameworks, software tools in the AI ecosystem just to enable AI, to enable more and more workloads to run on GPUs. So as I said, it's really easy to run workloads today on GPUs, on the VDS GPUs. Sometimes it's more difficult to run them on other chips, but I think with time it will become more and more easier. But so that's the ecosystem. And I think also NVIDIA is a great company. The GPUs and the technology that they are building is really advanced, and they are offering what the market will need in like 2 years time or 3 years time. So they are already offering right now. So they came out recently with the Grace Alpha offering. So that's a new offering, and they came out with really interesting technology there, and they are offering really big GPUs with a lot of memory. And they are really seeing what the market needs. And I think right now the market needs to run huge models with a lot of memory. Memory becomes like the bottleneck, and they have this offering already out, and that will support those big models. So I think NVIDIA is a great company, but as time will go, we'll see a second player. It will be really interesting to see who will be that second player.
So it sounds like AMD you probably put in the second position right now in terms of at least being a proper rival to NVIDIA. We've got the Amazon, the Google TPUs. Microsoft has recently announced that they're designing their own chip too. I don't know if I said Meta yet, but they've had their own chip and have one of the biggest clusters in the world as well. What about other companies like Samsung didn't come up there? Tesla? Do you see those two as potentially big timers?
Maybe. And Tesla, you forgot to mention Qualcomm as well. So Qualcomm is also a player that you don't want to underestimate. And then let's see, like Qualcomm and Samsung, they have their own offering. They might have an interesting offering when it comes to inference and running inference and running models at the edge. That's a market that will continue to grow, and there are opportunities for sure for players that are traditionally good in those markets, like Qualcomm and Samsung selling the edge devices. But the AI market is really different than previous markets. First of all, because software is really important. It's not just hardware. And these days you buy hardware and software, you must have those software at a stack on top of it. It's like it's a critical enabler. And also the AI space is moving so fast. So that the hardware manufacturers need to work fast as well. They need to provide more and more innovation in a faster pace. So in this AI space, I think it's any different than compared to previous markets that we saw.
Are there any other kind of smaller or specialist companies that you would suggest to keep an eye on? Like one that comes to mind for me, because we had CEO Andrew Feldman on as a guest, was Cerebras Systems, and they've made, as I'm sure you're aware, the biggest ever chip. Very different approach, obviously. Do you see them or other kind of smaller, what had been more niche chip companies being able to grow in a significant way?
Yeah, Cerebras, they have an amazing offering, actually, very unique, right? They have this huge chip. I haven't tried it, but it's really unique and it's really differentiated. And let's see, maybe they might have a lead opportunity. I think that the AI chip market is going to be huge, and even small players will get huge can get huge revenues. So this market is going to be huge with no doubt, and so there are opportunities there with no doubt.
How about just the rest of the world? Like, what do you think is kind of the state of, or the outlook maybe, for Chinese companies, any European companies? I mean, there's they kind of want to get your take at a higher level as well on just the geopolitics of all of this. Everybody's kind of waking up to the fact that this is somewhat of a strategic resource, right? I mean, it's maybe not quite oil, but it's increasingly, I think, kind of thought of as the next oil. Do you think countries, like China or, trading blocks like Europe can develop their own champions that can enter this top tier over the next few years, or is that just they're just too far behind and it's just still impossible?
Listen, this is a great question. And a couple of years ago, people spoke the opposite, right? People spoke about all the innovation coming out from China, right? People spoke about all the research and all the academic papers coming out from China. And people said, what's going on with the US? US is behind. That was the story like 2-3 years ago, right? The US is behind China. And see what happened. I think like what happened in the last 6 months or 1 year, that was amazing. It really showed the strength of the Silicon Valley, all the innovation and the technology coming from California, and with the open AI coming out with ChatGPT. So I think the US really showed the strength in the last 6 to 1 year. So we showed, things moved so fast. I think China now is behind. The geopolitical issues, right? That's a really interesting topic from different angles, right? On the chip angle, with this chip war happening, right? It's really interesting. Chips are strategic, not just to companies, to countries. And we're seeing this chip war with China. Really interesting stuff around AI. I think there is a race right now. There is a race in the Western world, but there is a race with China as well. And it's the amazing thing that it's just starting. Things are moving fast, so rapidly, right? You could think, like, for example, on the OpenAI with their ChatGPT. A few months ago, I heard that everyone spoke about how good ChatGPT is compared to others, right? That it's much better than anything else in the market. And I think now I'm starting to hear that other model providers provide very good models, sometimes even better than ChatGPT. So I think things are moving so fast. Technology gaps are being closed very fast. Right now, my analysis is that China is behind the US, but I don't know how fast that gap would be closed. Or you think it will be closed? Like, I guess it will be closed, but things are moving so fast. It's really difficult to predict. I think right now in the AI space, what will happen in 6 months from now, 1 year from now.
Yeah, no. Unfortunately, I totally agree. It's I always say my crystal ball gets real foggy after about 6 months.
Yeah,
I'm with you on that for sure. Obviously, I have a US-based perspective. I guess I'd love to kind of hear, do you think, and you spend time here and also in Israel, I'm interested in, is there a difference in worldview around AI dynamics? Here I think we honestly have a sort of, in my view, counterproductive framing of AI as this, new front in the contest or rivalry between the US and China. And I'm not really comfortable with the idea that we are creating these sort of seemingly, pretty severe escalations along the lines of trying to cut China off from leading edge chips. To me, that seems like it really increases the risk of other kinds of conflict because, for example, if they can't buy any of the chips from Taiwan, then maybe that makes the cost of disrupting the, production in Taiwan much easier for them to bear. Maybe I'm simpleton on that, but how would you describe the kind of, watching from maybe not a neutral country, but certainly a country that's, far from both of the, the two would-be hegemonic rivals? How does the rest of the world see this US-China dynamic?
I think, from my perspective, the geopolitical issues are really escalating in the last, 10 years, right? Things are being escalated. It's China and the US. Israel is a very small country, and we have a lot of political issues and a lot of challenges with our neighbors as well, right? So we're also really always in a need to protect ourselves against our other countries that are threatening us, you might say. So I think, for us, Israel, we use to be in this state of mind that there is danger around us, and there are countries that are aiming against us, right? And so, yeah, it's a big question. It's a huge question. I think I don't like to see things escalating and geopolitically wise. But it seems that it's going in that direction, right? But I'm optimistic in my nature, so I always hope that things will become better.
It's obviously impossible to characterize Israeli opinion briefly. I know there's a lot of disagreement and contention on everything, but you could either speak for yourself or try to characterize it however you would. But do Israelis see the view from this kind of middle part of the world? Does China look like an adversary from there? Obviously there's a lot of kind of local dynamics with neighboring countries, which are much more historically rooted. But does China look like an adversary from Israel?
From our perspective, Iran is the adversary. Iran is the number one adversary for Israel. And from our perspective, Iran is playing with China, and they're on the same side, from our perspective. I think that's one of the strengths of Israel and partnership between Israel and the US. From our perspective, Iran is the number one adversary. So, and from that perspective, I think the Israeli people are really seeing eye to eye with the American people. They don't like to see things escalating, but they also, on the other hand, they see the danger. And so I think for several decades already, collaborations between Israel and it's around those topics. But as I said, I'm optimistic. I'm always hoping for the best. But AI, for sure, coming back to AI for sure had an impact on that. Because now it's a race. Countries are being armed with AI technology, and AI technology is going to change the defense space. There's no doubt it's going to transform defense space. So for AI, chips are really important, are critical. So chips are strategic, AI is strategic for countries, and we will see, I think, the geopolitical state changes in the next decades, lots of because of AI.
Do you see that this sort of supply control is likely to be viable for kind of controlling who can do what with AI? I mean, that could be in the context of China, right? We could say there's these export controls and they can only buy H800s instead of H100s. And then I wonder, is that really going to work? Or is there going to be sort of some way to get around that, either by post manufacturing even, or maybe just very clever software work that could circumvent some of these imposed restrictions. And then I also think about that in the context of the just AI safety, dialogue or discourse in general. People are very kind of hopeful, and I'm not sure how realistic these hopes are, that maybe we could have a sort of know your customer regime for GPUs, and you can only buy so many before you got to have a license or a permit to do whatever. Do you feel like this is a sort of controllable enough resource that it's ultimately going to be fruitful to try to control the development of AI through controls on hardware?
That's a great point, right? People are speaking about regulating AI. And so coming from the computer angle, that can be an interesting angle, just controlling access to compute. So that's what's being done right now with the chip war between the US and China, right? They are just controlling the access to the newest GPUs. So China is not allowed to get access to the newest GPUs according to the US regulation, right? So now people are speaking about AI safety and about regulating the progress of AI and regulating how AI is being used. And so can that be controlled with compute? I don't know. Because right now to train, if you I'll become a little bit technical, but if you train huge models and you try to be to get to state of the art models, then you need a lot of compute. Right now, you have these open source models where you can train them on your data and fine tune it. You don't need the tens of thousands of GPUs to do that, right? Just yesterday, Meta, which I love what Meta is doing right now. They open source Llama 2, right? Open source Llama 2, it's free for research and commercial users, as they say. So that's really, really exciting. And now if you have those very capable models open source and people can take their own data and fine tune those models with using that data, they don't need a lot of compute. So then, right? So then controlling the access to compute becomes less relevant, I guess. So it's interesting aspect, regulating AI. I don't think it's an easy question. It's really, really complex.
That's probably a good note for us to leave it on. I know that, regardless of how all this develops, and there is tremendous uncertainty, you and the team at Run AI will be helping people get the absolute most out of their investment in GPUs. So, Dr. Ronen Dar, thank you for being part of the cognitive revolution.
Thank you, Nat. It was great fun. Thanks.
Omneky uses generative AI to enable you to launch hundreds of thousands of ad iterations that actually work, customized across all platforms with a click of a button. I believe in Omneky so much that I invested in it, and I recommend you use it too. Use CogRev to get a 10% discount.